What's up, guys? It's me, Sir Ernest, and today we're going to have an example on how to calculate the center of mass of a uniform thin rod. So, when you talk about uniform, that means the density or the mass density of this thin rod is a constant. Okay, so let's try to illustrate this problem. So, when you have a thin rod, this means that the thickness and the width is negligible. So what does it mean? It means that we're only focused on the mass distribution along the length of your thin rod. So for example, if we have this thin rod that is along the x-axis, okay? And say this is your thin rod along the x-axis, and let's say one end is at the origin, and let's just say that the length of this rod is b. Okay, so that means you can see that the center of mass will only be along the x. Okay, the center of mass along y and along z will be 0. Okay, so by definition, the center of mass along the x-axis would be equal to the integral of rho x dx. Here, our dl will be dx. Okay, divided by integral of rho dx. So what does it mean? So if we're going to choose one element with length dl, so let's say this element. So this element will have a differential length dl, which is dx. Okay, so what will happen is we're going to integrate from this point, origin, to x equals p. Okay, so let's do that. So here, because the density is constant, that means we can take out rho here, and then we just continue with the integral. So this is the x dx. And then the limits of integration will be from 0 to b. And then here we divided by rho dx integrated from 0 to b. So from here we can cancel, sorry about that, we could cancel rho. So that means, and then we can integrate this. This becomes x squared over 2, and then evaluated from 0 to b, then divided by x evaluated from 0 to b. So evaluating these limits, we now have 1/2 b. Okay, so this will be your uh, center of mass, which is what we expect. Because this is a uniform thin rod, the center of mass will be somewhere at the middle. So this is where your center of mass is located. So that's it. That's a simple example to illustrate how to calculate center of mass. In this case, center of mass of a uniform thin rod. So in the next video, we're going to talk about more examples in different dimensions for 1 dimension, 2 dimensions, and even 3 dimensions to help you understand how to calculate the center of mass of these objects. But for now, thank you guys for watching. I hope you learned something today, and I'll see you guys in the next video. Bye-bye.